Let's review some basic function operations. If I have two functions, f of x and g of x, and I want to add them, then I will say f plus g evaluated at x is equal to f evaluated at x plus g evaluated at x. If I wanted to subtract f minus g evaluated at x, then I could do that by subtracting f of x minus g of x. When I multiply two functions, f times g of x, that's f of x times g of x. And when I do division, f divided by g evaluated at x is equal to f evaluated at x divided by g evaluated at x, provided g does not equal 0. Now for each of these do not change the domain or the range. This one can change the domain and the range, particularly if you've got this g going off to 0 somewhere. Let's look at a couple. Suppose f is 4x plus 7 and g of x is 12 plus x. What are the f plus g and f minus g? Well, f plus g, pen here, f plus g, and a lot of times we drop this. It's f of x plus g of x. So f of x is 4x plus 7 plus g of x, which is 12 plus x. Now because these are being added, I can lose the parentheses. 4x plus 7 plus 12 plus x. Next, I need to gather like terms. So 4x plus x is 5x. And then my numbers are 7 and 12. 7 plus 12 is 19. The domain is the set of x such that x is a real number. Why? Because there are no restrictions on what x can be for either f, g, or the sum. For the range, it's a set of y such that y is a real number. Again, because as x becomes large in a negative sense, this is going to go toward negative infinity, and as x becomes large in a positive sense, this will become positive infinity, towards positive infinity. So what if I wanted to do f minus g? This one, we're going to have to be a little bit more careful with our parentheses. This is f of x minus g of x. So f of x is 4x plus 7. And I'm going to subtract from that 12 plus x. So now whenever we do subtraction, remember there's a negative 1 here, and we're basically going to distribute this negative 1 to each of these terms. So this is going to become, let's undo that. Thin my pen down a little bit. This is going to become 4x plus 7. You just write the first one. And now negative 1 times 12 is negative 12. Negative 1 times x is negative x. The number one mistake students make when they do this is they forget to distribute that negative to both terms. Now let's collect terms. This is 4x minus x, so this becomes 3x. Now 7 minus 12 here is minus 5. The domain did not change. It shifted a bit, but this is a set of x such that x is a real. because there are no restrictions on x. We're not square rooting a negative number, and we're not looking at 1 over 0. And the range is a set of y such that y is a real number. Suppose I want to do the product, and we've switched our functions here. So f times g of x is f of x times g of x. And this one is x squared minus 9 times x plus 3. Now we want to multiply this out. We can FOIL this out. A couple of things you can do. You can use the area model for this problem. Why don't I just FOIL it? So it's front. So this is going to be x cubed. That's front. Outside. So this is plus 3x squared. Inside, negative 9x. Last is negative 27. So FOIL is very useful when multiplying them out. My domain hasn't changed. My range hasn't changed. These both have, let's see, domain is the set of x such that, now we can do it this way as well. X goes from negative infinity to positive infinity. We can do this notation. And the range is the set of y such that y goes from negative infinity to positive infinity. Now, I want to do the quotient. Quotient's going to be a little bit stickier. So f divided by g evaluated at x. It's f of x divided by g of x, but I cannot have g of x equal to 0. And I see over here g of x equals 0 when x equals negative 3. So I see immediately I'm going to throw the negative 3 out of my domain. Let me go ahead and substitute these in. X squared minus 9 divided by x plus 3. Now I can simplify this. This is x minus 3 times x plus 3 divided by x plus 3. Now I can simplify this. I can cross out these terms because they're being multiplied. And I'm left with, this is equal to, it's equivalent to x minus 3. But I still cannot have x equal to negative 3. So my domain is the set of x such that x does not equal to negative 3. Now what does this do to my range? Well, the range, what you're going to do is this is going to be a line, and it's going to have a hole at x equal negative 3. Let me see what my range is. At x equals negative 3, then negative 3 minus 3 is negative 6. So what this is telling me, x can't equal negative 3, so y can't equal negative 6. So the range is going to be the set of y such that y does not equal negative 6. Because when x is negative 3 in this problem, y will equal negative 6. So we say these two functions are equivalent at every point except x equals negative 3. And we throw it out.